This video focuses on decimals as part of the Arithmetic Readiness Unit of Beginning Algebra. Decimals has 24 topics with timestamps in the description. Let's begin. Decimal place value, tenths, and hundredths. In this example, we're given 14.57 and asked to identify the digits in the tens place and the hundredths place. And to do so, I'll recall that the digit to the left of the decimal place is the ones, and the second digit to the left is the tens. However, going to the right of the decimal place, we don't have a ones place value. The first place value is tenths. And notice that this ends in THS, as does the rest of the place values to the right, with the next being the hundredths, which again ends in THS. So our number here has a 1 and a 4 in front of the decimal and a 5 and 7 behind the decimal. When we are asked for the tens place, that is without the THS. The tens place is to the left of the decimal, which here is a 1. So we have a 1 in the tens place, and the hundredths place does have that THS, so it will be to the right of the decimal place, which here is a 7. So we have a 7 in the hundredths place. Rounding decimals. And in this example, we're given the number 6.73 and asked to round to the nearest whole number. And looking at the whole number place value, we have the number 6. And to round, we look at the digit behind the place value that we would like to round to. And if that digit is greater than or equal to 5, we round up. And if the number behind our place value is less than 5, we round down, which means that the digit would stay the same. So in this case, our 7 is greater than or equal to 5. So our 6 gets rounded up to 7, and we drop any of the decimals behind the place value that we're rounding to. So the result of rounding 6.73 to the nearest whole value is rounding it up to just 7. Converting a decimal to a proper fraction in simplest form, basic. In this example, we're asked to write 0.6 as a fraction in simplest form. And I'll start by recalling that our place values here have 0 in the ones value, and the 6 after the decimal is in the tenths place. So that means that when we write this as a proper fraction, nothing would go in the ones place, and the 6, since the last digit, that is a decimal, is in the tenths place, that 6 would be written as 6 over 10. So if the 6 would have been in the hundredth place, if that was the last decimal, we would have written it over 100, but tenths place gets written over 10. And from here, we just need to see if we can simplify. Both 6 and 10 are divisible by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. So our simplified fraction has 3 in the numerator, 5 in the denominator. 3/5 is our simplified proper fraction. Converting a decimal to a proper fraction in simplest form, advanced. Here we're given the number 0.41 and asked to write it as a fraction in simplest form. And I'll start by looking at our place values. We have 0 in the ones place, 4 in the tenths place, and 1 in the hundredths place. So writing this as a fraction, there's no whole number part. We have only the decimal, 41, and the denominator is determined by the last place value, which here is hundredths. Hundredths meaning that that 1 is in the 100ths place. So our denominator would be 100, and then confirming that this is in simplest form. There aren't any whole numbers that divide evenly into 41 and 100, so this is in simplest form. Decimal addition with 3 numbers. We're asked to add these 3 decimal numbers, and to add, I'll want to first write the numbers vertically, aligning the place values. Starting with the 2.89, the decimals will need to be lined up, so the next number, 6.65, has these nice columns that I'll be able to add. And the third number would also align decimals with the 2 and the 4. With these decimals nicely aligned, we can now add, just as we would any other numbers, and our decimal will be in that same place. Starting from the right, 9 plus 5 would be 14, so the 4 would be in this place value, and we would carry the 1. Adding here, 8 and 1 is 9, plus 6, 15, plus 4, 19. So again, bringing down the 9 and carrying the 1. 1 plus 2 is 3, plus 6 is 9, plus 2 is 11. 11.94 is our total. Decimal subtraction, basic. We're asked to subtract these 2 decimals, and to add or subtract decimals, we need to rewrite the problem vertically and line up the decimals. 87.28 is the number that we are subtracting from, so that's the number that will be written on top. Then, lining up the decimals, the 2.37 would be lined up underneath it. This is subtraction. And since the decimals are lined up, I already know my decimal location and my solution will also be lined up. And from here, we can subtract just like whole numbers. Starting on the right-hand side, 8 minus 7 is 1. 2 minus 3 needs to borrow. So borrowing 1 from the 7 and bringing it to the 2, 12 minus 3 is 9. 6 minus 2 is 4. 8 doesn't have anything being subtracted, so that comes down as just 8. And with those decimals lined up, we can tell that our solution is that 84.91. Decimal subtraction, advanced. We're asked to subtract these 2 decimals, and we'll need to write the subtraction vertically, starting with the number we're subtracting from on top. Lining up the decimals, we would write the 8.58 on the bottom, and then subtracting, I know my decimal place will still be lined up in my solution, and I would subtract from the right to left just as I would whole numbers. And since there's no digit above the 8, I can replace that with a 0. And 0 minus 8 means I would need to borrow from the left to make that a 10. 10 minus 8 is 2. 8 minus 5, 3. And 9 minus 8, 1. Lining up the decimals essentially means that I didn't have to think about where the decimal would go, and our solution is just 1.32. Decimal addition and subtraction with 3 or more numbers. We're asked to do this calculation that involves both addition and subtraction. In following order of operations, addition and subtraction just happens left to right. So our first calculation will need to be 7 plus 8.51. I would line those up vertically, 7 and 8.51. When I add, notice I lined up the decimal that would have been behind the 7 to get this vertical alignment. Our total will have the same decimal alignment, moving right to left, 0 plus 1 is 1, 0 plus 5, a 5, and 7 plus 8, 15. So this first part has been added to 15.51, bringing down the rest. I would continue to move left to right, and the next operation is subtraction, starting with 15.51 and subtracting 2.8. Again, we have the decimals lined up, so the solution will have that same alignment. And subtracting this time, 1 minus 0 is 1. 5 minus 8, I would need to borrow a 1 to get 15 minus 8, which is 7. 4 minus 2, a 2. And 1 minus 0, 1. So we've done the subtraction and have 12.71. We have one more operation. We need to add that 4.1. Adding, we would again line up the decimals. So 12.71, 4.1. Adding this time, on the far right, 1 plus 0 is 1, 7 plus 1, an 8, 12 plus 4, a 6, and 1 plus 0, 1. So 16.81 is our solution. Word problem with addition of 3 or 4 decimals and whole numbers. We're told that Eric found 4 pieces of wire in his tool drawer, and we're given the lengths in centimeters, 14.1, 1.08, 15, and 2.8, and we're asked to find the total length of the 4 pieces. Total length means that we'll be adding up these 4 lengths, and since some of these are decimals, we'll need to be careful to align the decimals when we rewrite it vertically. So 14.1, 1.08. The 15 doesn't have a decimal, but if it did, it would be on the right-hand side here, and 2.8. These are the values for the lengths that we'll need to add, and since the decimals are aligned, our new decimal will be in the same place, and otherwise we just move right to left as we normally would when adding multiple numbers. On the far right hand side, we only have the 8, so 8 plus nothing would be 8, and then 1, 0, and 8 would add to 9. 4 plus 1 is 5, plus 5 is 10, plus 2, a 12, carry the 1, 1 plus 1 plus 1, 3. Looking back at the question, we're looking for the total length in centimeters, so our solution is 32.98 centimeters. Word problem with subtraction of a whole number and a decimal, regrouping with zeros. We're told that Raina cut away 2.77 meters of rope. Before making that cut, she had 4 meters of rope, and we're asked how much does she have left? Since she started with 4 meters, cut some amount away, to find out how much she'll have left, we'll be using subtraction. And we know that she started with 4 meters, but she cut away 2.77 meters. Cutting away is subtraction. And we've got the decimals lined up. Even though the 4 doesn't have a decimal, I can put one in. And for the decimals to the right, I can also use zeros as placeholders. And I can tell that to subtract 7 from 0, I'm going to need to borrow. The next digit to the left is also a 0, so I'll need to borrow from the 4, making it a 3. The next digit would be a 10, but I need to borrow from that 10, making it a 9 for the last digit to be 10. From here we can subtract 10 minus 7 is 3, 9 minus 7, a 2. The decimals always line up, so our solution decimal is in the same place. 3 minus 2, a 1. So we know that Raina has 1.23 And our units are meters, 1.23 meters left. Multiplying a decimal by a whole number. To start this example, I'll rewrite the problem, and unlike addition and subtraction, we don't line up the decimals. We line up the digits furthest to the right and then use those columns to organize the multiplication and ignore the decimal until the last step. Otherwise, we're multiplying just as we would if there were no decimals. 7 times 2 is 14, so 4, and carry the 1. 7 times 6 is 42, plus the 1, 43. The last digit goes down, and carry the 4. 7 times 5 is 35, plus 4, 39. With no more carrying, I can bring the 3 down. And lastly, we count up all of the decimal places. So here's 1, 2. We have a total of 2 decimal places. So our decimal needs to move 2 places to the left. 1, 2. So the result of this multiplication is 39 with the decimal behind the 9, 0.34. This is our solution. Decimal multiplication, problem type 1. To multiply these two numbers, I'll start by rewriting, and notice that for multiplication we don't need to add up the decimals, but we do need to add up the digits on the far right, and then we can use these columns to organize our multiplication in the same way that we would for non-decimal numbers. Starting with that lower digit to the right, the 6. 6 times the 6 above it is 36. The last digit goes down and we carry the 3. 6 times 0 is 0 plus 3 gives us 3. And 6 times 4 is 24. With nowhere to carry the 2, we bring it down. So we've multiplied by that last digit. We'll now turn to the next digit to the left, the 2. Multiplying the 2 by the 6 gives us 12. The 2 goes underneath our current digit, and we would carry the 1. 2 times 0 is 0 plus 1. And then 2 times 4 is 8. We've multiplied through by 6, shifted 1 space to the left, and multiplied by 2. Since the other digit is 0, there's nothing to multiply. We can just add up these columns. 6 plus 0, a 6. 3 plus 2, 5. 4 plus 1, 5. And 2 plus 8, 10. And our last step when multiplying by decimals is to count the total number of decimal places to the right for the numbers that we were multiplying. So here's 1, 2, 3 total decimal places. So this decimal needs to be moved 3 places, 1, 2, 3 to the left, giving us 10.556. This is the solution for this multiplication. Multiplication of a decimal by a power of 10. We're multiplying here by 100, which is a power of 10. Other powers of 10 being 10, 1,000, 10,000, and so on. And the reason this is its own problem type is because there's a handy shortcut that we can use when we're multiplying by a power of 10. Starting with the number that's being multiplied by a power of 10, we can look at that power of 10 and count the number of zeros, 100 having 2 zeros, and we can move the decimal that many places. Since we are multiplying by 100, that would of course make our number bigger, which indicates to me that those 2 decimal places will be to the right, 1, 2. Our new decimal place will be after the 8. So this would be a 68.7. And the shortcut of moving the decimal 2 times for the 2 zeros makes this much easier than actually going through the multiplication. Word problem with multiplication of two decimals. In this example, we're told that a construction crew has just finished building a road. The crew worked for 11.5 days, and that if they built 2.8 kilometers of road each day, then we're asked to find the total length of the road that they built. So 2.8 kilometers each day, 11.5 days. We could find the total length by multiplying. And to multiply decimals, we line up our digits vertically so that the digits to the far right line up. In this case, the decimals happen to line up as well. But what we're really doing here is lining up the right-hand side of both of these numbers. From here, I can ignore the decimals until the end and start off by multiplying by 8. 8 times 5 is 40. So the 0 goes below the 8, and we carry the 4. 8 times 1 is 8 plus 4, a 12. So the 2 comes down, and we carry the 1. And then 8 times 1 is 8 plus 1, a 9. Notice that when we multiplied by 8, the digits started underneath the 8, and we kept our columns. Because next we will multiply by the 2. 2 times the 5 gives us 10. The 0 goes below the 2, and we carry the 1. 2 times 1 is 2, plus 1, a 3. And then lastly, 2 times 1 is 2. So we've multiplied by both of those digits. We can now add each of these columns. 0, 2 plus 0, 9 plus 3 is 12. Carry the 1, 1 plus 2, a 3. From here, we'll look back at the decimals, and I see that I have 1 decimal place on the top, 1 decimal place on the bottom for a total of 2. So we move our decimal 2 places, 1, 2. The decimal goes between these two 2's to give us 32.20. Looking back at the question, we were asked for the total length of the road they had built. Our length is given here in kilometers. So the road's length after 11.5 days is 32.2 kilometers. Word problem with decimal addition and multiplication. In this example, we're told that Alonzo is buying ribbon for wrapping presents. A large present requires 8.5 feet of ribbon. A medium present requires 5.25 feet, and a small present requires 2.5 feet. We're also told that Alonzo is wrapping 5 large presents, 6 medium presents, and 1 small present, and asked how much ribbon will he need. So from the description, we have 5 large presents, each one requiring 8.5 feet, 6 medium presents, each requiring 5.25, and then 1 small present requiring 2.5. So to find the total, we would need to do each one of these multiplications and then add those totals together. Starting with the 8.5 and multiplying by 5. 5 times 5, 25, carrying the 2. 5 times 8 is 40, plus the 2, 42, bringing down the 4. And then 1 decimal place means 1 decimal place. So far, we have 42.5 feet, but that's just the large presents. Moving to the medium, each of those requires 5.25 feet, and there are 6 of them. So multiplying here, 6 times 5 is 30, carrying the 3. 6 times 2, 12, plus 3, 15. 6 times 5, 30, plus 1, 31. This time, the numbers that we are multiplying have a total of 2 decimal places, so we would also need 2 decimal places. This is 31.50. That's the amount for medium. For the small one, there's only 1, and so that will be just 2.5 feet. When we were multiplying these decimals, we lined up the right-hand sides, but now these 3 values need to be added, and to add, we need to line up the decimals. So moving this 31.50 underneath, we would align those decimals. We also need to add that one small package, aligning those decimals. And our final calculation will be to add these on the far right, 0, 5 plus 5 plus 5, 15. 1 plus 2 is 3, plus 1 is 4, plus 2 is 6, and 4 plus 3 is 7. Unlike multiplying, our decimals here are aligned, so the resulting decimal is also aligned. How much ribbon will Alonzo need? 76.5, and the units we were given were feet. Division of a decimal by a whole number. In this example, we're asked to divide the decimal 2.34 by the whole number 9. And to do this without a calculator, we'll set up long division and recall that the order is sort of the opposite, where the second number, here 9, is the number outside, and then underneath the long division sign is the first number, 2.34. And since the number that we are dividing by here, 9, is a whole number, our decimal will just move straight up. And from here, we just have regular long division. 9 doesn't go into 2, but ignoring the decimal, 9 goes into 23 2 times. 2 times 9 is 18. 23 minus 18 of 5, bringing down the next digit, which is 4. 9 goes into 54 6 times. 6 times 9 is 54, and subtracting, we have 0. So we have an exact answer here of 0.26, which can be written as 0.26. Division of a decimal by a one-digit decimal. We're asked to divide these 2 decimals, and since we're not using a calculator, we'll set this up as long division, putting the first number underneath the long division sign, and the second number out in front. And now that we have long division, we can only divide by a whole number, so the decimal out in front will need to be changed to a whole number by moving the decimal place to the end of the number, which is 2 spaces, meaning I'll have to also move the other decimal point 2 spaces. Now that we've rewritten this so that the number out in front is a whole number, just 8, and the number underneath has the decimal at the end, 216, we can use long division. 8 goes into 21 2 times. 2 times 8 is 16. Subtracting the 16, 21 minus 16 is 5, bringing down the next digit, which is 6. 8 now goes into 56 7 times. 7 times 8 is exactly 56. So subtracting gives us 0. So doing this division, our solution is exactly 27. Division of a decimal by a 2-digit decimal. We're asked to divide these 2 decimals, and to do so without a calculator, we'll want to set up long division with the first number underneath the long division sign and the second number out in front. And with long division set up, Our number out in front can't be a decimal. It has to be a whole number. So I would need to move this decimal 2 places to bring it to the back of that number, which means I would also need to move the other decimal 2 places, filling in zeros as needed. We can now rewrite this problem with the whole number 46 on the outside and 9,890 on the inside. If a decimal is needed, it would be here. And from here, this is just normal long division. 46 goes into 98 2 times. 2 times 46 is 92. Subtracting, we have 6. Bring down the next digit, which is 9. 46 goes into 69 just once. 1 times 46 is 46. Subtracting now gives us 23. Bringing down the next digit, 230. 46 goes into 230 5 times. 5 times 46 is exactly 230. Subtracting gives us 0. So our solution is exactly 215. Division of a decimal by a power of 10. In this example, we're asked to divide 77.5 by 10, and we have 2 options here for how to proceed. We could set it up as long division with the 10 in front and the 77.5 inside, or we can use the fact that we're dividing by a power of 10 as a shortcut, where we use the number of zeros behind the 1 to determine how many times we move the decimal. We had a similar shortcut for multiplication. However, for multiplication, we were making a number larger by moving the decimal to the right. And for division, we'll be making the 77.5 smaller. So we will move the decimal to the left. We have 1 0, so we move the decimal 1 place, giving us 7.75. Long division on the left will always work. However, for numbers like 10, 100, 1,000, and so on, powers of 10, moving the decimal based on the number of zeros is a handy shortcut. Word problem with division of 2 decimals. In this example, we're told that Chow volunteers for 0.8 hours each day, and that he volunteered for a total of 11.2 hours. And from that information, we're asked how many days he volunteered. So to do this calculation and find out how many days Chow volunteered, I would take 11.2, the total number of hours that he volunteered, and divide that by 0.8, the number of hours he volunteered each day. And for that calculation, we would use long division, recalling that the 0.8 goes out front with the 11.2 underneath. And for long division, the number we're dividing by in front has to be a whole number. So we would need to move this decimal 1 place to make that an 8, which means we would also need to move this decimal 1 place, moving it behind the 2, so that we now have 8 on the outside and 112 on the inside. From here, we can do our long division as usual. 8 goes into 11 once. 1 times 8 is 8. Subtracting gives me 3. Bringing down the 2, 8 goes into 32 4 times. 4 times 8 is exactly 32. So with no remainder and the decimal directly above, the division gives us 14. And since we were asked how many days, our solution is 14 days. Word problem with decimal subtraction and division. In this example, we're told that today 7 friends went out for lunch. Their total bill was $52.21, with tax and gratuity included, but that one of them ordered only soda, and so that one person only needed to pay $2.17, with the rest of the 6 friends ordering the same daily special. So how much did each of those other friends need to pay? And from the description, we know that we're using both subtraction and division. And the first thing that we need to do is subtract out that one friend who is going to pay $2.17. So the total for the remaining 6 friends will be the total, which is $52.21, minus the soda, which is $2.17. Once we find out how much that is, we'll know how much the other 6 friends will need to split. And for a subtraction, we would need to rewrite this vertically. 52.21 minus 217 with the decimals lined up. I know my decimal location will be right below, and then we can just subtract. Starting on the right, 1 minus 7, we would need to borrow. 11 minus 7 is 4. 1 minus 1, 0. 2 minus 2, 0. And 5 minus 0, a 5. So $50.04 is what the other 6 friends have to split, meaning we would take that 50.4 and divide it by 6 people. And to do our division calculation, we would set up long division with the 6 in front and the 50.04 underneath. We're dividing by a whole number, 6, so no need to move the decimal. I know the decimal will be directly above. 6 goes into 50, 8 times 6, a 48. Subtracting, we have 2. Bringing down the next digit, which is 0, 6 goes into 20 3 times. 3 times 6, an 18. Subtracting gives us 2. Bringing down the 4, 6 goes into 24 4 times. 4 times 6, 24. With no remainder, we have $8.34. This is the amount that the 6 friends would have to each pay. Converting a fraction to a terminating decimal, basic. In this example, we're asked to write 73/20ths as a decimal. And when converting fractions to decimals, we'll use the fact that fractions are really just another way of writing division. So this would be 73 divided by 20. And for long division, we would write this as 20 on the outside and 73 inside. And when we start this division, we can see that 20 goes into 73 3 times. 3 times 20 is 60. Doing the subtraction gives us 13. And since we're writing this as a decimal, I would need to keep going, introducing zeros behind the existing decimal. I could always add another 0 to bring down, and the decimal in my answer would be directly above. From here, we can continue because 20 goes into 130 6 times. 6 times 20, 120. Subtracting gives us 10. We still have a remainder, so we would need to continue by adding another 0, bringing this 0 down. We now have 20 goes into 100 5 times. 5 times 20 is 100. Subtracting gives me 0. And now that I no longer have a remainder, this worked out to be exactly 3.65, which is a terminating decimal. Converting a fraction to a terminating decimal, advanced. And here we're writing 5/16 as a decimal. And as before, we will be starting with that denominator, using it to write our long division, and then using the 5 as the number underneath. And the first thing that we notice here is that the 16 does not divide into 5. 16 is bigger than 5, but we can introduce a decimal in the 5, and that would allow me to put zeros behind the decimal. As before, the decimal will always be straight above, but now we can look at 50 and say that 16 does go into 50 3 times, putting my 3 at the top. 3 times 16 is 48, and when we subtract, we would get 2. And we can keep going by just adding more zeros that we can then bring down. 16 goes into 20 one time. 1 times 16 is 16. Subtracting, we now have 4. Continuing to add zeros and bringing them down. 16 goes into 40 twice. 2 times 16 is 32. And I can see I'm going to need a little more space because subtracting now gives me 8. And I need one more zero to bring down. 16 goes into 80 5 times. And 5 times 16 is 80. With no remainder, we have a terminating decimal. 0.3125 is our solution. Converting a fraction to a repeating decimal basic. We can see here we're writing 17/6 as a decimal, and we are to use a bar to indicate which digit or group of digits repeats. So in the process, I do anticipate that I'll see some digits begin to repeat, and setting up the long division, I would start with the 6, that being the number outside, and then inside we would have the 17, and from here we can start long division. 6 does go into 17 2 times. 2 times 6 is 12. Subtracting gives me 5. And I need to continue the long division. But since there's no decimal, I can still introduce a decimal and start adding zeros. And that decimal will be in the same place above. We can now bring this new 0 down. And 6 goes into 50 8 times. 8 times 6 is 48. Subtracting gives me 2. I can add another 0. 6 goes into 20 3 times. 3 times 16 is 18. Subtracting, we get 2. And I'm starting to see a pattern here because using one more 0 to bring down, I again have 6 goes into 20 3 times. I would again get 18. Subtracting would give me 2. And this process would continue on and on, each time getting 20 and another 3 in our decimal. So since those 3's are the only digits that repeat, I would write this as 2.83 and then a bar over the 3 to indicate that it will continue to repeat.